Hey guys, I have your notes here for 4-6 day 1. And up to this point, you've looked at sine graphs and you've graphed several of them. You've looked at cosine graphs and you've graphed several of them. What I'm hoping you realize is how much alike sine and cosine graphs are. So I've drawn them just on some blank space here on my app. And you know your sine graph starts at 0 and you see one cycle and it ends at 2 pi before it starts to repeat itself. So the sine graph is a bunch of this shape starting at 0, ending at 2 pi, and it's just copied over and over and over again. That's what it is. Of course, without transformations, it starts at 0 and it ends at 2 pi. That's what the sine graph is. It's just repetition over and over and over again, same values and everything. And it takes this far, 2 pi, before it starts to repeat itself. Cosine, pretty much exactly the same, except whereas sine starts at the origin and kind of like ready to create an up hump, cosine starts with a y value of 1 and it already starts in the middle of an up hump. That's the best way I can think to put it. And so when you look at cosine, one cycle of cosine is from the peak of an up hump to the peak of the next up hump. So cosine has a period of 2 pi, and then what you see is it just repeats itself again. It's just a repetition of the same exact shape over and over and over again, and both of these graphs go on forever in the positive infinity direction and in the negative infinity direction. So the sine and the cosine waves, if I could draw them perfectly, which I can't, the sine and cosine waves are exactly the same wave. They just start in 2 different locations. And they both have a period of 2 pi before they start to repeat themselves. Now, in this worksheet that you did, you came up with the shape of the graph on your own. So many of you didn't know what the shape of the sine graph looked like until you made it. So what you did was you filled out this table, and using the hand trick or the table, whichever one you do, you said, okay, I know that the sine of 0 is 0. I know that the sine of pi over 6 is 1/2. The sine of pi over 4 is radical 2 over 2. The sine of pi over 3 is radical 3 over 2. The sine of pi over 2 is 1. And then, now we're in quadrant 2. So I've got to use a reference angle, reference angle, reference angle. Probably use the unit circle. Oh, look, now we're in quadrant 3. Reference angle, now my fractions are negative. Reference angle, negative, reference angle, negative, and then it goes back down. Still negative, still negative, still negative, 0. Do you see how all of these y values kind of increase in height until 1? And maybe you can see it better in decimal form. These y values increase in height until they hit 1, and then they start to decrease in height until they're back down to 0. That's what causes the hump of the sine graph. And then we've got another hump, but it goes downward. So negative, more negative, more negative, negative 1, less negative, less negative, less negative, 0. And then, we could look at them in cosine too. If I continued this, my next angle would be, oh golly, let me think in terms of 6, 12 pi. My next angle would be 13 pi over 6, and my y value would be positive 1/2. It's going to repeat itself. Now, here's what I want you to check out. I did the same exact table for tangent. And of course, I use the hand trick. So I'm going to do radical these fingers over radical these fingers. And I simplified it. So let's see. Aha. Tangent. Now, don't look at sine and don't look at the sine fractions. Just look at the tangent fractions. How about in decimal form? So the tangent of 0 is 0. Can you picture what that ordered pair looks like on a graph? Yeah, it's at the origin. What about when you have an angle of pi over 6? Now your y value should be a positive 0.6. And when your angle is pi over 4, now we're at positive 1. And then now we're at 1.7, and all of a sudden at pi over 2, your tangent is undefined because you had to go 1 over 0 to get this, and boom, you blew up. Now we're in quadrant 2. All tangent fractions are negative in quadrant 2 because of ASTC. So I'm going to use a reference angle. I'm going to use a reference angle. I'm going to use a reference angle. And the tangent of pi is 0. Now, you see how they start at a negative value, less negative, 0. And now positive, more positive, undefined. Okay, so check this out. From 0, positive, undefined, negative, undefined. Watch this. They repeat. They start to repeat much more quickly than sine does. 0, 0.6, 1, 1.7, undefined, negative 1.7, negative 1, negative 0.6, 0. Tangent started to repeat right here. When does sine start to repeat? Over here. It takes sine a span of 2 pi before it starts to repeat itself, not tangent. It takes tangent a span of 1 pi before it starts to repeat itself. So we're going to say that because tangent starts to repeat itself after 1 pi, the period of a tangent graph is pi. The period of a sine graph is 2 pi. It takes this long to complete a cycle before it starts to repeat itself. Tangent, the period is 1 pi. It only takes this long before the graph, we complete one cycle and the graph starts to complete itself. Repeat itself. Alrighty. Now, on to 4-6 day 1. I think, though, before we get to graphing our own tangent graph, I just want to show you what a tangent graph looks like because they're completely different than sine and cosine. Keep in mind, there are places where the graph of tangent blows up. Now, you should kind of know from pre-cal first semester, you should kind of know what a blow up looks like on a graph. It could be a hole, it could be an asymptote, but it blows up at pi over 2, and it blows up at 3 pi over 2. And since it repeats itself, it's going to keep blowing up. It blows up at 1 pi over 2. It blows up at 3 pi over 2. Where do you think the next blow up is going to be? Complete the pattern. 5 pi over 2. Again, 7 pi over 2. Again, 9 pi over 2. Go backwards. It blows up at pi over 2. It's fine at 0. Back up. Where's it going to blow up that way? Negative pi over 2. Negative 3 pi over 2. Negative 5 pi over 2. And so on and so on and so on. So on a tangent graph, you're going to see a whole bunch of asymptotes. Blows up, blows up, blows up, blows up. So let me just show you what a tangent graph looks like. It's kind of cool. Sine, cosine. By the way, never blow up. Never, ever, ever do sine and cosine graphs blow up. Domain, all real numbers. Tangent, however, yep, that's what the graph looks like. Whoa. And I've only drawn a portion of it. But remember how I said blows up at pi over 2? There's an asymptote, and I kind of make my asymptotes red so they kind of stand out and you don't cross them. blows up at 1 pi over 2, blows up at 3 pi over 2, would also blow up at 5 pi over 2, but I kind of got tired of drawing. Blows up at negative pi over 2, blows up at negative 3 pi over 2, and so on. So you've got all these asymptotes that kind of repeat themselves. But here's what's important. Look what happens between two asymptotes. So I could focus on any of these little, things, but let's focus on the one at the origin. So the one at the origin, it's kind of bounded by this asymptote holding it in, and this asymptote holding it in. The graph passes through the origin. The tangent, when my angle is 0, is 0. So here's what I want to do. Remember how we did 5 points for sine? We go middle, up 1, middle, down 1, middle. And we do that. We kind of have our own little pattern for cosine. We've got 5 points for tangent, 2 of which are asymptotes. So point number 1 is going to be an asymptote at negative pi over 2. Point number 2 is going to be another asymptote at pi over 2. That leaves 3 more points. We're going to choose the one in the center, 0, and then we're going to do halfway and halfway. So what's halfway between 0 and pi over 2? Pi over 4 and negative pi over 4. So we're going to look at this one and this one. What is my y when x is negative pi over 4? What is my y when x is 0? What is my y when x is positive pi over 4? All right, let's get started. So I went ahead and started my table. We already know that we're going to have an asymptote here and here. Tangent is undefined. Halfway between negative pi over 2 and positive pi over 2 is 0, so I put a 0 in the middle of my table. And then halfway between these two and halfway between these two. Now let's figure out your y values. So probably what you're going to want to do for tangent, holy moly. This one is going to be on your table or on your hand. This one is going to come from the unit circle. This one's going to come from the unit circle. This one's going to come from hand or table. It's in quadrant. Oh, whoa. This negative angle is actually in quadrant 4 because you go backwards for negative. So ASTC, so this is going to be negative. And negative pi over 2 is going to be here. When you do your y over x, you get undefined. All right, so we have asymptotes there. And then we have 3 fairly nice points to graph. So here we go. Let's draw one cycle of a tangent graph. So I'm going to come out here at negative pi over 2 and try to make it the same distance, positive pi over 2. And if you want, you can go ahead and draw those asymptotes. That's 2 of the 5 things I need to graph. And then I need you need those marks on your graph. This is going to be positive pi over 4, negative pi over 4. And then on your y-axis, make a tick mark for positive 1 and a tick mark for negative 1. Now, graph those 3 points. I've got this x value and this y value. I've got the point 0, 0 and pi over 4 comma 1. They look like a little segment, but you know it's supposed to look like a cubic. Really, it looks like a parent cubic. So try to make it as curvy as possible. Kind of like that. You've drawn one cycle of the tangent graph without any transformations. You've drawn one cycle. Big difference. When you draw a cycle, for sine, you start at the origin and work your way right, usually, without any transformations. You start at the origin, you work your way right to 2 pi. Same with cosine. You start where x is 0, and you work your way right. We're gonna approach tangent a little differently. We're gonna center our tangent graphs at the origin. This is the cycle that we're going to draw. So it's going to go a little bit behind the origin and a little bit to the right of the origin. And then we're going to use this for our transformations. We might shift them a little bit one way or another. We might scrunch the asymptotes in. We might spread the asymptotes out. Okay, so let's answer some questions. First of all, do you remember what I said the period of a tangent graph was? Some of you do. The period is pi. That's how long it takes before it starts to repeat itself. And you can see that from negative pi over 2 to positive pi over 2, like 1/2 pi to 1/2, this has a distance of pi. Vertical asymptotes. There are a lot of them. So here's how I'm going to have you write them. Nope, let's do domain and range first. Range is easy. How low does it go? How high does it go? Range, all real numbers. Domain. Do all x values work? Good heavens, no. This x value doesn't work. This x value doesn't work. Nope, 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 and so on and so on and so on and so on. So I'm not going to have you list them all, but I'm going to have you write it in a very mathematical way. Okay? This might be like new to some of you. Let's start with a basic one. Let's start with pi over 2. So I'm going to say for my domain, x cannot be pi over 2. X cannot be pi over 2. What else can't it be? Well, look at how we're incrementing upward. How much is it from here to here? 1 pi. And then 1 pi more. And then 1 pi more, and then 1 pi more, and then 1 pi more, and so on. All right, so here's how we're going to write this. Domain. X cannot be pi over 2. Plus every pi increment, every multiple of pi beyond that. So I'm going to write it like this. All n is n represents any integer. For example, it could represent 0. If this was 0, it wipes this out. X can't be pi over 2. You knew that already. What if n is 1? X can't be 1/2 pi plus 1 pi. So x can't be 3/2 pi. So these pi increments, this is where the repeat comes in. This could be negative. That's what sends us back the negative direction. X can't be negative pi over 2, negative 3 pi over 2, and so on and so on. So, if my domain excludes these, where are my asymptotes located? Our asymptotes are located at these locations. There, and all the pi increments from that point on. Okay? So, domain, this is saying we can't allow x to be these numbers because my function blows up there. Vertical asymptotes is saying, tell me again the location where your function blows up, and you say it blows up at these locations. Alrighty, now let's start looking at transformations. I've kind of already gone ahead and color-coded for you, just like I did sine and cosine. Feel free to pause the video and copy down, use your highlighter. So the period's the distance between the two vertical asymptotes. That should, if you've been paying attention up to now, that should make perfect sense to you. So the period is pi. This is different than sine and cosine. Way different. Sine and cosine, the period was 2 pi. A is going to represent a vertical stretch. B still represents the frequency. However, remember how we used B with sine and cosine? We did 2 pi over B. That's because our period for cosine was 2 pi. We have a new formula for a tangent. Our new formula for tangent is the period of tangent over B. New formula for tangent. You've got to remember that. Of course, C is a horizontal shift and D is a vertical shift, just like normal, just like what you're used to. Alrighty, now, there are like, oh, dang it. There are little equations you may use to figure out where your asymptotes need to go. Or I'm just going to show you how I graph them. I don't use a little equation. I just use my knowledge of fractions, really, in order to graph them. So for the first one, the only transformation going on is inside here, so I colored it all pink. Amplitude is still 1. B is the number in front of x. That was easy. Now what do you do with it? Well, you put it in your new little tangent formula, pi divided by b, and 1 pi divided by a half is 2 pi. You know what that means? This graph has been transformed. Normally, you would see your asymptotes have a width of pi. Not on this one. This one's undergone a horizontal, horizontal what? 1/2? Horizontal stretch, because it's backwards from what you would think. So where your asymptotes normally have a width of pi, now our asymptotes are going to have a width of 2 pi. So my tangent graph is going to be wider because there's a horizontal stretch going on. Okay, and there's no horizontal shift and there's no vertical shift, so our tangent graph is still centered at the origin. So here we go, ready? Let's draw your asymptotes first. Center at the origin, here's what I want you to do. I want you to span a width of 2 pi. I don't mean go 2 pi this direction and 2 pi this direction, because that would have a width of 4 pi. That's too wide. I want your width to be pi. It's 2 pi. So I want you to go 1 pi here, 1 pi here. Okay, that one's negative, that one's positive. Now, from here to here to here, is that a width of 2 pi? Yes, it is. That's where your asymptotes go. Put them there. That's 2 of our 5 points. Here are our other 3. Amplitude is still 1. So my 3 points that I'm going to plot are going to be at the origin. I need one halfway here, down 1. That's going to be negative pi over 2, down 1, right there. And I need one halfway here, up 1. That's going to be positive pi over 2, up 1. There you go. Draw them. So all I did was I looked at the period, figured out how wide it needed to be, drew my asymptotes, made my 3 points that my asymptotes kind of hold in my tangent graph, and so I made those 3 points and within my asymptotes and drew it. Okay, next one, normal, normal. So my period is just pi, except we're going to have to shift it right pi over 4. So let me show you what a normal tangent graph would look like. Normally, you would do this. Normally, that's where your asymptotes would go. And then you would need this x value and this x value, right? Normally, I would draw an asymptote here and an asymptote here, and I would go point, 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 whoosh. Okay, shift it. We need to shift it right pi over 4. So you know how we would have had asymptotes here and here? We would have had, I drew them lightly, we got to shift them over. Hang on. This will be better. You'll be able to watch me shift them if I make it one solid line. So, moving right, I'm moving right. So I'm moving right this distance. This is the width. So it would have ended here. Move it right that much farther. Make yourself a tick mark. What are you going to call it? One pi over 4, 2 pi over 4, 3 pi over 4. Okay? Now I'm moving my asymptotes. I'm shifting my asymptotes right this far. Here I go. There are my new asymptotes. New asymptotes. Now, 3 points. Ready? Find your way to the middle. Make a point on the x-axis. I put positive 1 on my y-axis and negative 1 on my y-axis. Now, ready? So this is halfway. So at this halfway point, you need to make a dot on negative 1. Dot down here. And this halfway point, positive 1. Connect them. There you go. Okay, moving on. Next one. Normal, 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 not normal. So the amplitude is 1. The period, since b is 1, the period's going to be pi, just like normal. There's no shifting going on. So go ahead and set up your asymptotes. Negative pi over 2. These are normal. Normal. Set them up. They're not moving. On your y-axis, where you would normally go positive 1 and negative 1, let's go a couple and a couple. Halfway. Negative pi over 4, positive pi over 4. Haven't drawn it yet. So everything is normal except there's going to be a flip and it has to go down 1. Okay. Normally, this is where your 3 points would be. Flip them. Flip them. So, put this one up here. That one stays. Put this one down here. Hang on. Don't draw it yet. Wait for me. See how I flipped it? What else do I need to do to it? I flipped it. What else do I need to do to it? I need to move it down 1. Okay. Here we go. Down 1. So see this point? It's now down 1. See this point? It's now down here. See this point? It's now down here. Okay? And I know it's kind of easier on my program to do just because I can grab it and drag it down, but I think that helps you see the visual of where it was and where it needs to go. Everything just gets moved down 1. Alrighty, last one. Couple of transformations going on here. First of all, A is 2. So you know how on your y-axis I usually have you go 1 and -1? Well, A is 2, so we're going to have a vertical stretch. So let's go up to 2 and down to -2. Okay, so that pretty much takes care of the A equals 2. Let's work on the asymptotes. Remember in front of x is 3, I put pi over 3. That's the period of the graph. So, can you handle this? There's no shifting going on. So we're centered on the origin, okay? I need from your left asymptote to your right asymptote, I need that to be a distance of pi over 3. From here to here needs to be a distance of pi over 3. How much would half of that be? Well, what's half of pi over 3? Pi over 6. So I need you to make a tick mark out here, and I need you to call it pi over 6. Therefore, I need you to make another one out there called negative pi over 6. And just double check real quick. This has a distance of pi over 6. This has a distance of pi over 6. 1 pi over 6 plus 1 pi over 6 is 2 pi over 6. 2 pi over 6. Oh, yeah, there I go. My period's pi over 3. We're almost finished. We need 3 points. One is obviously going to go at the center. Oh, hold on. Let's draw our asymptotes. Here, here. We're going to have 3 points. One's going to go at the center. One's going to go halfway. Ooh. This is the last challenging thing I'm going to ask you to do today. What is halfway from 0 to pi over 6? So what's half of pi over 6? I went a little too far. It's pi over 12. Pi over 12 and negative pi over 12. All right, so you got one of your points. We need one halfway and down here, remember, because A was 2. Need one down there. And I need one halfway and up 2. Whew. very stretchy. Okay? Alrighty, good luck with those fractions. Again, determine your period, figure out how wide you need to make your graph. We're pretty much going to center these around the origin, unless, of course, you need to take your asymptotes and shift them one way or another. All right, good luck, guys.